Hi, and welcome to another lesson about challenges in streaming processing in operationalizing streaming pipelines. So, do you remember in the, I think, module 1 when I talked about the difference between streaming and batch processing, and I said that the batch processing is usually easier to apprehend, to work with, and one of these reasons is the debugging. So, when you process data in batch, you have the whole data set you want to process available. So even if your job fails and you want to make some ad hoc investigation on the reasons, or you want to explore the data and understand better the potential failures in the future, well, you have all possibilities to do it because data is there. Streaming is an unbounded process, so data is continuously incoming and you don't have any way to say, hey, in the future my data will look like this. And the same comes from the debugging. If you want to debug your data, there is no data available or easily queryable like for batch processing, and it makes the whole process much more difficult, much more challenging. But there are some different strategies that you can apply and you can use to make it better and hopefully much more efficient. And among these strategies, the first strategy is to switch into the data address. So in data systems, the streaming broker is not the single data source. Very often we also add this data address storage for the batch use cases. And it's if you have some failure in your streaming job, you can apply the exactly same debugging mode as for batch pipelines. So identify the failing piece of data on top of this data address storage and add necessary debug to the failing job in this in streaming, and just change the input for the job, and instead of consuming streaming data, consume the data from the address storage and analyze the outcome, and eventually do some much more iteration on top of these steps. And here, of course, you have to change the input, but the good thing is that you can also additionally do some ad hoc querying and maybe combine it with other things, or give some other operation to better understand and fix the problem. Moreover, you can also really find small piece of data, like for example one file containing the file row, and very easily, even without running the job, you can just analyze the record and try to understand what's going wrong. So this data address exploration is a very handy tool for debugging streaming pipelines. Of course, if you have the batch layer for in your architecture. Another strategy is the silent reprocessing with debugging. So here we are assuming that the real-time job failed, it cannot be restarted, and in these steps we identify the code, the snippet that caused the exception. We add some debugging, like for example in the try-catch block, or maybe in the calling the call stack in different methods, and we compile it, we run it, and we analyze the outcome. So we analyze the logs. But the key part here is that this job shouldn't generate any data. It should be a no-op job, because you don't want to reprocess past data maybe from yesterday and send it to your consumers. You just want to understand the problem reason. Of course, it takes time because you will need to find the places, you will need to add the logs, you will need to deploy the code, you will need to probably change the offsets to process, and it can be complex, it can be time consuming, but at least it gives you the production condition, the logs from the production conditions. So these are two big strategies I have in mind. I have used with success in streaming jobs I'm dealing and have been dealing with, and I can also give you some more tips for the streaming jobs. So the first tip is to start small. So if you're developing a new project, for example, and you have millions of rows to process, you don't necessarily need to process them all. Instead, just identify a small subset of consumers, small subset of data that you will work on, and that way if you need to analyze the output, it will be much easier because you will have less data to analyze. And probably this first analysis you will do it with your eyes and not an automated SQL query or any other automated job. And as a consequence, if you have any issues in your code, you will be able to isolate them easier from this small data set. Another one is to dataset profiling. So again, if hopefully you have data address, you can apply some SQL. If not, you can write a simple consumer that will just process data and maybe write it to some data profiling tool. And here you can already show the buggy or problematic data places without necessarily running or writing the code. Another tip is about cutting the code. So here is for the case when you have a problem and you completely don't know what's causing the problem. So by problem I mean maybe not all data are written to the output, or maybe some temporary or unexpected failures. And here the idea is to, if you have your code of 10 lines, you simply divide it into multiple chunks and you test the first three lines. If they succeed, you test the next 5, or you take the first 5 or 6 ones. If they succeed, you take the remaining ones, and so that you can isolate and test iteratively what's going on with the code. It's good when you don't have the code base knowledge, you don't have the project experience, but of course it takes time, because each time you recompile the project, you rerun the code, you see the progress, and so forth and so on. You can speed up this process though if you use notebooks or any interactive tools like shells, because generally you can start your shell with the jar reference or the wheel reference of your job, and later line by line at each step of the execution and see whether it fails or not. And besides cutting the code, you can also, or rather you should, think in advance. So you should add logs, you should probably approximately, of course, because you haven't had any issue yet, but you can approximately identify the pieces of code that can cause you problems and add enough logging to understand the errors without necessarily running the debugging version of the code, so from the second strategy. And here the outcome is the faster bug fixing, because generally you see a log message, you know, okay, it happened there, it happened with that data, so if I take this data and apply it to my unit test, for example, I'm able to isolate it and fix without necessarily deploying the whole application and consuming millions of rows in my streaming job. After that, there is the iteration. So keep this small scope. You don't have to understand the big picture, the whole picture immediately. You can isolate different parts and iterate that way. So for example, if you have some job composed of filtering, mapping, and writing, so IO generation, IO part, you can start by taking the input row that causes you problems, apply it on top of the filter. If it works, that's fine. You pass to the map. If the map fails, where you have your bug. If not, otherwise you move to the IO and check the database writing. Maybe there is something wrong in this last step. So that way you keep the debugging under control. You are not lost in your process, and additionally you ensure that the code you are analyzing that causing it is the code causing real problems. There is also this famous tuple of monitoring and alerting. So leverage them as much as you can, because dashboards will show you the things going wrong, but the alerts will directly tell you that the things are going wrong, and that's something very useful at daily basis. And finally, there's this tip about speaking. So programming is a team activity, and when you explain the bug to someone, is also known under the rubber duck debugging term, or simply when you ask a more experienced person for help, you will definitely be able to understand the problem and fix it much faster, and or eventually identify the root cause also much more easily. So I don't want to scare you. Streaming processing is very exciting. It's not something that you should avoid unless you really want to stick with batch processing your whole life. But the streaming processing is great. You discover different paradigms, you discover different tools, different problems, and debugging is one of these problems. And I hope that with these few tips and strategies, you will be able to work much more better with the streaming pipelines. Thanks for watching, and see you in the next lesson.